Welcome to the video for page 24 in your packet. In this video, we're going to discuss the difference between linear equations and nonlinear equations. Let's take a look at linear equations to begin with. When we see the word linear, of course, we see the word line in the first four letters. We know that any linear equation graphs as a straight line, and when the equation is written, we know that x is to the first power, or we call this the first degree. So let's take a look at our first example here. There are two types of linear functions. There are linear proportional functions, or there are linear non-proportional functions. So in number 1 and in number 2, let's discuss the difference. Well, we know both of these will graph as a line. So each are linear. But the key difference is when you take a look at a linear proportional function, these particular linear functions graph right through the origin. To be proportional, you must pass through the point 0, 0. And if you look at the equation, we see it's a very simple equation where x is to the first power. An equation can look like this. Please write down these examples. 2 times x equals y. You can even have a coefficient that's a fraction. 3/4 times x equals y. Or maybe even a decimal. 2.35 times x equals y. But notice there's no b value, no y-intercept. That's because in this particular case, your intercept is 0. So, to recap, if you're looking at a graph, it must go through 0, 0 to be proportional. And if you're looking at the equation, well, it's a very simple equation that takes the form k times x equals y. And remember that x is to the first power. When it comes to linear non-proportional equations, there are a few characteristics to look for. Please sketch a quick coordinate plane in your notes. And when it comes to a non-proportional linear equation, it's going to cross that y-axis at some other point than 0, 0. For example, this intercept is positive 2. The actual location is 0, 2 on the coordinate plane. So when we write this equation, we know that our intercept will be 2. Now this equation looks almost like a proportional equation where x is to the first power. However, in this case, there will be a y-intercept. Something like this. 3 times x plus 2 equals y. Of course, x is to the first power. And our intercept, well, that's positive 2. Remember, these equations can look several different ways. They can look like this. 3 4/4 times x minus 1 equals y. X is still to the first power, even though we don't always write it. Or perhaps like this, -5 plus 4x equals y. And once again, x is to the first power. Number 1 and number 2 represent linear equations. But let's take a look at some nonlinear examples. Nonlinear basically means that it's not a straight line and x is not to the first power. Let's take a look at a few different examples of nonlinear equations. Number 3 is a quadratic function. In this case, x is to the second power. Number 4, cubic function, where x is to the third power. Number 5, x is shown inside the absolute value symbol. This is called an absolute value function. And in number 6, this is an inverse function, where x is in the denominator. Now, if we write x in the numerator, we would write it like this: x to the negative first power equals y. Now, how do each of these look when we graph them? Well, take a moment, pause your video, and draw a coordinate plane for number 3, 4, 5, and 6. When you graph a quadratic equation, it graphs as a parabola. Please take down these notes. A parabola has a curved shape to it. When we graph a cubic function, it graphs in almost an S shaped, but once again, curved. An absolute value function graphs as a V. And finally, when you see an inverse function, it graphs like this. You can see that the inverse is made up of curved parts as well. So, this is just a basic introduction into functions. Make sure you have all the notes, and when you're ready, go on. This concludes page 24.